The new topic, quadratic equation. We all know that the quadratic equation is of this type: ax square plus bx plus c is equal to 0. But if I want to write a quadratic polynomial, I'll write quadratic polynomial as ax square plus bx plus c. That means if a polynomial is equal to something, it will become an equation. So today we are talking about the zeros of the polynomial. Earlier I had taught you by graphical method. Now we will learn by coefficient method. My question is, what is this a? So a is called to be the coefficient of x square, right? That means the number multiplied by x square is called to be its coefficient. Same way, what is this b? So b is called to be the coefficient of x. Same way, what is c? The c is a constant term, as it does not contain any x term, but x is still there with the power 0. So we can say c is a constant term. So we are having, for polynomial p of x, ax square plus bx plus c, we have three constant terms which are a, b, c. Now if I compare this polynomial with the zeros, so let us take alpha and beta to be the zeros of this polynomial. Question arises, why I have taken two zeros? Because you remember I told you it is a quadratic polynomial. Quadratic polynomial will have two zeros. So let us take, I'm not taking any particular value 3 and 5 or something like that. Let us take alpha and beta to be the roots of this polynomial. So our polynomial will be, that means the value of x will be either alpha and x will be beta. There will be two values of x. So we'll have x minus alpha to be one of the factor, and same way x minus beta also will be one of the factor. So both will be factors and even the product will be factor. So we'll have x minus alpha into x minus beta. The product of these two terms will give you such a polynomial having roots alpha and beta. And it's not necessary only the product of x minus alpha and x minus beta only. If I multiply this term with a constant k, so this also will give you the same polynomial having the same roots alpha and beta. So we can say any polynomial ax square plus bx plus c will be equal to k into x minus alpha into x minus beta. Let us expand this. K is a constant term. If I open it, it will be x into x, x square, minus alpha into x minus alpha x into minus beta x, and minus alpha into minus beta will become plus alpha beta. So finally it will be k into x square. If I take minus common over here, alpha plus beta into x plus alpha beta. Right. Now if I now compare it with the standard form of a polynomial. Okay, let us compare it. Okay, so you can see x is alone over here. The coefficient of x is 1. While here we have x square is multiplied by a. So let us divide this whole term by a. X square plus, if you want to see a by a, b by a, and c by a. This as it is. So if you compare these two things, now it is equal. X square is equal to x square because a upon a will become 1. And let us now compare the second part. So we'll get b upon a is equal to minus into alpha plus beta. X is common, will get cancelled. Same way, C upon A is equal to alpha into beta. You remember what I told you about alpha and beta, they are the zeros. So we can take this minus sign over here. So we will get alpha plus beta is equal to minus B upon A is the first result, and alpha beta is equal to C upon A. This shows the relationship between zeros and the coefficients of the polynomial. So I can say the addition means the sum of zeros is equal to minus B upon A. What is actually minus B upon A? B was the coefficient of x, if you remember, and A was the coefficient of x square. So I can say sum of the zeros is minus into coefficient of x upon coefficient of x square. Same way, product of the zeros is equal to the constant term upon the coefficient of x square. So this whole theory, what we have learned today from here till here, is regarding the relation between zeros and the coefficients of the polynomial. So this was regarding quadratic polynomial. Yeah.